Hello, everyone. Mr. Minnick's my name. Math is my game, and on today, this is the third of 4 parts to this. This is TI Topics. I originally recorded some lessons for this back in 2015, and I had a student guest narrate the beginning of it, and he asked an interesting proposition. He asked, how famous do you have to be assassinated rather than murdered? That's an interesting thing. Anyway, I'll let you think about that on your own time. Today what we're talking about is quadratic. We'll just say quadratics. We'll just leave it at that, quadratics. So chapter 4 in Algebra 2 is the chapter where we study quadratics, everything about quadratics, whether it's a quadratic function, whether it's a quadratic expression, factoring functions, finding their minimums, their maximums, their x-intercepts, their y-intercepts. So our first example, we're going to look at a standard form quadratic function, something like negative 2x squared plus 5x minus 3. 3 big things I'm going to be asking you for on these, and that's going to be the x-intercept. Maybe there aren't any x-intercepts. Maybe there's 2. Who knows? The y-intercept and the vertex. Now, of those 3, there's one of those 3 that we should be able to find with a standard form function without doing any work, without even touching the calculator. Who knows what it is? The what? The negative 3 is our y-intercept. So our y-intercept is the order pair 0, negative 3. So we shouldn't even have to do any work on a calculator for that. X-intercepts, 2 times 3 is 6. This thing could factor. Don't know that it does. The vertex is going to be a fraction. It's going to be a mess. I can tell you that right now. So anyway, on our calculator, I'm going to start a new document. So I go home. I said I go home, and I start a new document, and I'm not saving any changes, and I'm going to add a graphs page. And my function, I believe, was negative 2x squared. Was it plus 5x minus 3? Okay, plus 5x minus 3. Boom. So I see that my parabola opens in a downward fashion. I can kind of see that the graph actually does go through the x-axis. There's one command, and one command only, that we're going to need to do most of this activity. Does anybody remember the magical command to find all your critical parts of the graph? There's a country music singer that has PV amplifiers named after him. I think his last name's Adkins. Trace. So how do I get to the trace command? Menu, trace, and graph trace. Watch what happens when you press that. It snaps right to the y-intercept. That's pretty cool. And all we got to do is use our directional pad, our D-pad, our directional pad, just cursor over. And the cool thing is that the calculator will stop at some cool points. It tells us one of our x-intercepts is 1, 0. That's cool. So one of them is 1, 0. Well, maybe I'll change colors. So my one x-intercept is the point 1, 0. Remember, an x-intercept and a 0, they're the same thing. Cursoring over, it tells me my maximum. Remember, Mr. Minnick does not like decimals. So as a fraction, what's that maximum going to be? So a certain number of fourths, right? It's going to be what, 5 fourths? 5 fourths. So the vertex is the ordered pair 5 fourths, comma, 0.125. That's 1/8. Nice, good. So the vertex is 5 fourths, 1/8. And there's probably one more x-intercept if we continue to walk over there. There it is, 1.50. Now, I don't like decimals. 1.5 would be 3 halves. 3 halves, 0. What do you think? Piece of cake? So the y-intercept we got for free. And like I suspected it early on, that actually does factor. Could have factored. We could have found the x-intercepts that way. But the whole idea behind this lesson is we're using the TI-Nspire to do this stuff. So that's a standard form function. Standard form functions, y-intercept, we don't even need the calculator, the other stuff, it's handy. Okay. Example 2, moving right along. I said I'd try to keep this under 10 minutes. Example 2, we're going to look at y equals 1/3 times the group x minus 15, the quantity squared, and then plus 11. There it is. So again, same kind of 3 things I'm going to be looking for. I'm going to be looking for the x-intercept, or intercepts if there are any. Going to be looking for the y-intercept. Going to be looking for the vertex. The vertex. Which one do we get for free on this one? Not the y-intercept. We don't. Well, the slope is 1/3. You can kind of think of 1/3 as the slope of telling us how high the parabola is going to be. It's going to look a little bit wider, but we get the vertex. Sure, we get the vertex. What is it? 1511, right? Remember the x-intercept, the x part of the vertex is counterintuitive. So we get our vertex for free. We don't have to do any work to get that. But on the calculator, let's go ahead and graph this. I see people starting a new document all the time. If you're working on the same particular assignment, maybe you just want to insert a new problem. Insert, doc, insert a new problem, and I'm going to insert a graph page. I said a graph page, and this is the fraction 1/3. I started with my fraction template. And then in the quantity in parentheses, I'm going to have x minus 15. I got to put my quadratic, my squared at the end of that. I got to put that in the right place. And then it was what, plus 11 at the end? So I press enter and I don't see anything. Because my window's messed up, isn't it? There was somebody earlier today that had a great idea. They said, let's use this zoom feature. Menu, window zoom, and let's zoom out. And nothing happens. Because you got to tell the calculator where do you want to zoom out from. We know our vertex is 1511, right? So I need to click somewhere. I should probably click somewhere in the first quadrant. Got him? Maybe it'll be handy if I turn on my grid. So I'm going to go menu, view, grid, lined grid. Maybe that might help me find my vertex. I don't know. Maybe it won't. I'm going to hit escape to get out of the zooming utility. And I think I screwed up my, I think I moved my graph, if I'm not mistaken. Yep, I did. Okay, so again, trace, graph trace, menu. Whoop, let's try that again. Escape. I'm going menu, trace, and graph trace. This time it didn't snap to my y-intercept. Anybody know what the y-intercept is? 0 what? 86. That's going to take a while to use my D-pad to get. There's a faster way. I could maybe look at the table. You know how to insert a table to your document. On a computer, if you want to print, it's Alt-P, right? Or Control-P? How about Control-T? Control. You don't have to hold Control. Control-T will get us to a table. And I want to know the value of y when x is 0. So we said it's 0.86, and there it is, 0.86. 0.86. Cool beans. So our y-intercept is 0.86. 0.86. And what about our x-intercept? What do we say about the x-intercept? It doesn't exist. It's not available. It's not applicable or not applicable. Or as I've been saying all week long, there ain't one. So that's example 2. We feeling all right about these? Good. So vertex form, we get the vertex for free. The third type of function, I said we got 4 examples. The third type we're going to look at is this form. Let's go with 5, x minus 6, x plus 7, like that. So we want our vertex, we want our x-intercept, and our y-intercept. We should get one of these 3 parts for free without doing any work. If you remember anything at all from chapter 4. What do we get for free on this? We get our x-intercepts, right? The one x-intercept is positive 6, so we get 6, 0. And what's our other x-intercept then? Negative 7, 0, right? So we get our x-intercepts for free. To find the vertex, we're going to have to use our graphing utility. So doc, insert a problem, a graphs. What do we have hanging out front of 5? So it's 5 times the group x minus 6 times the group x minus 7. I said x minus 7. And I better put a parenthesis in here. There it is. X plus 7, I'm sorry. Thank you. Good looking out. Okay, so x plus 7. Awesome sauce. Don't know what happened there. X plus 7, and somehow my one factor disappeared. X minus 6. There it is, 3 weeks later. Okay. So menu, trace, graph trace, graph trace. It snaps right to my y-intercept. I like that. That's awesome. So my y-intercept is 0, negative 210. 0, negative 210. And the vertex, probably going to take a little bit. There it is, negative 1/2, negative 211. Negative 1/2, negative 211. Do we feel all right about using the calculator to do these things? Okay. The last thing is finding the zeros. Remember, finding the zeros is the same thing as solving an equation. So what if we had something like y equals x squared minus 8x minus 13? I know that's going to have x-intercepts. I could use the graphing utility, or I could use this other command on a calculator page. If I just look at this expression, it's kind of the same thing as solving the equation x squared minus 8x minus 13 equals 0. It's kind of like solving that equation. Now, back in chapter 4, we probably would have completed the square, and we would have got 4 plus or minus, what's 13 plus 16? Is it 29? We would have got 4 plus or minus the square root of 29. But anyway, I'm allowing you to give me decimal answers today. I know that's chalk that one up for the record book. So anyway, we're going to go doc, we're going to go insert, we're going to go problem, calculator page, and there's a command that'll find the roots of a polynomial. Remember it? Polyroots. Just type it in. P-O-L-Y. Who do we appreciate? Polyroots. It was x squared minus 8x. Was it minus 13? And then I need to put a comma x. Boom. There it is. Now, you're saying, well, that's not 4 minus the square root of 29. Well, is it? 4 minus the square root of 29 is the one thing, and 4 plus the square root of 29. There they are. And for once, I'm allowing you to give me decimal answers, and I'm going to ask you to round it to 2 places. Did you know the calculator can round for you? Here's the last thing, and this is something you probably didn't know. If you go home 5-2, the calculator can round to as many decimal places as you want. Where it says display digits, float has to do with sig figs. I know some of you in chem are doing that right now, aren't you? Float has to do with sig figs. Fix will round to that many decimal places. So if I ask you to round to the nearest hundredth, if you fix that, it'll round this for you, because some people don't know how to round very well, and it'll give you the answers to however many decimal places you want. Got him? It's been real. It's been fun. I hope it's been educational. Shout out to the future Mr. Minnick for being so awesome. I'm sorry this was over 10 minutes. Shout out to my 6th period class for being the best Algebra 2 class I have this year. Thank you. Have a great day. Bye. Good.